Our next speaker is again a guest speaker from Europe. It's Miklos Petridisz from Datapao, and he is going to talk about managing machine learning life cycles with MLFlow. So, Miklos, do you hear me? Yeah, I see you are already sharing the
Yes,
screen.
yes, I do hear you. Thank you. Can you guys
Perfect.
hear me? See my
Yes, we
screen?
do.
Everything's perfect.
Yes, we hear you and we
All
see
right.
your screen. You can start.
All right. So welcome everyone. I hope everyone's having an amazing day. I'm currently in Hungary, speaking from Hungary. Um, and yeah, my name is Miklos Petridisz, and I have an amazing topic prepared for you, managing the machine learning lifecycle with MLFlow. Now we have some time constraints, and so if you want to have questions, just drop a line on the QA tab, Q&A tab, or Slack, and we'll go through it. Even if we don't have time, I'm gonna stay a little while, and we're gonna get through it and sort this out. So quickly about me, as I said, I'm Miklos Petridisz, but everyone calls me Mike, so feel free to call me Mike. I'm a data engineering consultant at Datapao. We are a cloud data engineering and data science services company covering the entire data and cloud transformation journey from enablement through architecture to implementation. Now, we work a lot with online manufacturing and pharmaceutical companies. So the use cases that I saw are mostly from these industries, but just so you know, all the general conclusions of this talk are going to be very similar. Yeah, apart from Datapao, I'm a big data, cloud computing, real-time data processing, and data platform TA at Central European University. And I was in the part of instructors, like in the instructor team at this year's Spark and AI Summit. If you haven't heard of it, I very much advise you to check it out. There are some amazing gems there. So as you can see, I am coming from a data engineering background, and I do not consider myself as a data scientist. So if you have some hardcore ML questions, by the end of this talk, I'm going to definitely connect with my colleagues, my data science colleagues, and we're going to sort out any problems that we might encounter. So as you can see, my LinkedIn is open, email is open. So yeah, just message me anywhere. And yeah, so let's dive right into today's topic, managing the machine learning lifecycle with MLFlow. So starting with cross-industry standard process for data mining, CRISP-DM. This is a concept that is harder to be pronounced than what it is, really. If you haven't heard of it, don't worry too much. It's in layman's terms how businesses work. But don't say this to your business colleagues. This is mostly from an engineering point of view. So what we can conclude right away when looking at this diagram is that it got introduced in 1996. So managing the machine learning lifecycle is nothing really new. It's been around for a while now. It's not that we came up with it in like 5 years ago, right? And it has many components, starting with the top left corner, like business understanding. This is the part where you determine the business objectives and the goal of the data analysis. Try to get it right because you don't want to solve a problem that is not like a non-existing problem. Moving on to data understanding is going to be the part where you collect relevant data, do some plotting, do some exploration, and check the quality of the data. With data preparation, it's where you do the cleansing and the transformations, the modeling part. It's crucial to validate your models. In the evaluation part, you're going to test these models and hope that they are going to be in line with the business objectives. And lastly, deployment, aka putting everything into work in the business. I guess it comes without saying that this is where the data mining pays off. So yeah, this is CRISP-DM in a nutshell. Of course, you can check it out anywhere if you're interested in like some of these parts in depth. There are a lot of articles and content about it. Why I introduced this is that what we can conclude right away from this model is that we are going to be faced with some problems in the long run. So, we are going to be using a large number of tools to implement each phase of this machine learning lifecycle, right? So as a developer, you might use TensorFlow with Kafka, with deployment environments such as Kubernetes. And, also there are like other pain points, like we want to know some information about who trained the model, when that model was trained, track the hyperparameters of our models. And on top of this, like deploying model itself, like ML machine learning is painful. And how are we going to do this in a standardized way, in a reproducible way? So we have these pain points, and I really introduced this because this is what MLFlow is about. Our talk is going to be based on MLFlow, of course. But what is it? It's a open source end-to-end machine learning lifecycle, like a platform, an open source platform. Now it's undergoing heavy development, and there is actually an incorrect thing in this slide. We are already at the 1.11 version, but when I was making it, it was 1.8. So it's undergoing heavy development. And behind the design decisions of MLFlow lies two components: the open interface. So it works with any ML library, any algorithm, any deployment environment or language. There are some language constraints, but we are going to have a hands-on demo, and I'm going to show you everything. And on the other hand, it's open source, so developers or you or anyone can actually extend it. Now, current release components of MLFlow right now include tracking, projects, models, and the model registry. And tracking, well, so if you are into ML, and most probably you are into ML if you are in this talk, you're doing some modeling, right? And you get to some models, but then you change some parameters, and I'm not talking about hyperparameter tuning or like grid search, but you are actually just exploring your models. You want to know what you did 2 hours ago. And it happened to us with a Datapao in a manufacturing use case that, we had some models, some special predictions, but they didn't seem like great at that time. So we just moved on. And later that we realized like, oh my God, we actually should go back and roll back to previous versions, because what we did was like make sense. And so this tracking kind of thing is covered in MLFlow, and you can read a lot more about it. We are going to go in depth with it with a hands-on demo as well. But yeah, just so you know, MLFlow.org, I would really much advise you to check it out if you want to go in depth, right? Yeah. So project is about how are you going to package your models in a way that you can pass it over to your data science fellows or colleagues. You have to have a standardized way, so the environment and everything to be set up. This is in a nutshell about projects. Models is a general purpose model format that lets you deploy to production environments. And lastly, the model registry is to store, annotate, discover, and manage models in a central repository. So this is MLFlow, and like in a nutshell, of course. But let's do the hands-on demo. We are going to use a lot of things. I would advise you to take a screenshot of the slides, although I'm going to share all the presentation with you. But here you will find the notebook that we are going to use on Databricks. Also, we set up an MLFlow server for you that you can use for free, and yeah, replicate everything that we are going to do in the next session. So let me share a new screen, because I would like. Actually, I don't have to share a new screen because I think I shared my desktop. Can you see my browser right now?
Yes, we do.
Amazing. All right, thanks. So I already set up a cluster, so we are up and running. But what are we going to do? We are going to set up a LightGBM model in Spark. If you're not familiar with LightGBM, it's a gradient boosted tree-based learning algorithm. It is just a machine learning algorithm, so don't worry too much about it. We are going to create an MLFlow experiment, check it out on the UI, do some tracking, and register the model in the MLFlow model registry and get it ready to be tagged as a production environment. As I said, you can replicate this at home, on Databricks as well, but you can go fully on-prem. There are some instructions here. One thing I want to show you is that if you will want to do this on Databricks, you would want to install libraries on your cluster beforehand, like the ML Spark and the LightGBM. So these two are going to be here. All right, so let's get started. Let me just set us up and running to import some Spark related thing. And yeah, we are good to go. So we are going to read in some data and train a LightGBM model. So what are we doing here? We are having a Parquet file. It's a columnar storage format. And if you haven't heard of it, I very much advise you to check it out. Please don't use CSVs. If you are using CSVs, just convert everything to Parquet, and everything gonna be a lot faster. This is probably the best takeaway. If you haven't heard of Parquet, it's so much more important than this talk. So yeah, your future self will feel a bit thankful. So we have some data. The data is from a power plant in Istanbul. This is real data, and you will find some references about it in the notebook. So we are actually just reading this path. We have a data frame reader, and we are reading this Parquet file into a variable called power plant row. And we are just picking up the columns as we wish, like temperature, etc. And don't worry too much if you don't get the code. This is Spark related stuff. You don't have to use Spark to run MLFlow. I'm just quite familiar with it, and that's why I'm using it. All right, so let's check out data. Fortunately, we don't have like a million rows like sometimes. So what do we have? We have the outside temperature, the steam speed of the power plant, the atmospheric pressure, humidity, and what we are trying to predict is the power emission. So power emission is what we are going to predict. All right. So let's build a Spark machine learning pipeline. What do we have here? We are assembling all our feature vectors into an output column called features, excluding the power emission. And then we are throwing a LightGBM gradient boosted tree on top of it, and we call this a pipeline. Now, let me emphasize that LightGBM is an object variable, and that is what we are going to tune. So let's do some simple machine learning stuff. Let's train this pipeline. We are doing let me run this. Sometimes I forget to run code. That is crazy. All right, so we up and running. Okay, so let's train the pipeline. We are simply doing a random split. We are going to feed the pipeline on the train, transform the model on the test, and and display it. And display is just a Databricks related stuff. It just displays it in a nice format for us. All right, so now we have the same columns, right, as we had before, but now we have a features column, a dense features column, and predictions. But we don't know much about these predictions. These are numbers, but how precise they are, we don't know that. So these are just numbers. They don't say too much for us. So let's get down to it, and let's get in depth about like how precise this is. We are going to evaluate these predictions. For this, we are going to use two metrics, the RMSE, the root mean square error, and the R squared. If you haven't heard of it, although this is probably you've already heard of it, but what you have to know is that we are aiming for the lowest possible RMSE and the highest possible R squared, closest to 1. All right, so let's check our predictions, like how precise they are. We are just simply printing these predictions so we have an RMSE of like around 3 and the R squared around 1. Well, I'm not satisfied with the RMSE right now. It's kind of high. So let's do some more. This time, let's set it up in MLFlow. We are going to import MLFlow. If you want to use this on-prem or use a standalone server that we set up for you, please uncomment this line and feel free to use it and break it. But now we are using Databricks and Azure. So I'm going to just, it's in the, like MLFlow is in there. So we are just going to set a new experiment. We are going to call this experiment DataFast experiment. And this is going to result, as we don't have an experiment yet, this is going to result in a new experiment. And in the workspace tab, if you click there, you will see that it has come up. So let's check it out. Okay, so this is just very simple. This is the MLFlow embedded version in Databricks. We don't have anything here. This is really just, we haven't logged anything, so this is kind of empty right now. So let's do something interesting. So we will do the MLFlow tracking now. But now this is Python code. We are using the with statement. We are doing the same as we did before. We are retraining our model. And we are going to log some parameters like the method, the number of leaves, the max depth, And with MLFlow, you can log 4 things: parameters, like your hyperparameters, and you can also log metrics, like the RMSE and the R-squared. We are going to log these. You can log also artifacts, so files, images, and your models. So yeah, we are just simply logging these right now to MLFlow. Nothing crazy. Some simple, just the RMSE, R-squared, and yeah, so we have it. Let's check it out on the UI. Now I just have to refresh it because it is not auto-refreshing. So we see now, okay, that's great. So we have this log here. It's successful. We can see that we have the max depth, which is -1, so it's just a default, the number of leaves, which is the default, and we can see the R-squared and our RMSE here. So, it's just very simply, let us like look behind the curtains. It's just a repository sort of the log. Now let's log some more, because we are not really satisfied with these metrics, right? We want to get to some better predictions. So we are going to log everything this time, not just the RMSE and the R-squared and stuff like that. We are actually going to use the paramdict. This is going to log the like alpha and etc., like other parameters for us as well. And we this time are going to set the max depth to 3. Let's check out, if it changes our predictions. We really like it. We are doing some trial and error here. Yeah, and this is an experiment. An experiment is this is a run. So we are just trying to tackle this problem. All right, let's check it out. Okay, so it resulted in a higher RMSE. We don't like that. We want to get to the lower RMSE, and actually in the lower R-squared, that's not good. But also in the UI already, you can check that it came up as well. Yeah, so now we are just actually appending this kind of repository of our logs. Now we are doing a more manual run this time. Because we use the with statement, so it just concludes right away after we run this cell. This time we are not going to do that. We are going to just leave it up and running and do some other stuff. We are going to set the max depth to -1 and the number of leaves to 50, and we are doing the same, like nothing crazy, logging the same stuff that we've done before. And let's check the results, what we get back. Okay, this is actually looks very appealing. Now you see we got to the lower RMSE. So let's say we like it this time. You can actually, I will share this notebook with you, and you can do your own stuff and test it out yourself. So now we have 3 logs here, one of which is still running. As you can see, as you remember, we didn't use the with statement this time. And now we can compare them. So let's compare them. So this is just like a nice MLFlow kind of stuff that we can compare these models. You can see we have the number of leaves like 50, 31, 31, and the RMSEs. This is basically the most crucial part that we are trying to look at. And we have some plotting option as well. So we can just check the max depth and like the RMSE, and we can see that. Sorry, 1 second. Okay, we can see that we have like 2 results in like the lower max depth field, lower RMSE field, and one with the higher max depth with the higher RMSE field as well. You can explore yourself this further. We don't have much time to do that together, but I'm just introducing you to this feature of MLFlow. Okay, this is not such a good plot right now, but what you can see is that we are aiming for we are going to find the lowest RMSE in somewhere in the lowest max depth and the highest number of leaves kind of territory or field. So this is kind of a great exploration for us to see, how to tune the model. All right. So as you can see, we like this. We said it. We like this RMSE and this R-squared. So we are going to just log this in a Spark format, but you don't have to log it in a Spark format. You can use whatever you want, really. Like most of the stuff is already there. But yeah, we just use Spark, and we are going to give this a name called Spark model. Also, this is still running. So let's just finish this run. And so it finished. We didn't get an error. That's great. I'm happy. The demo gods are on our side today. All right, so let's check, because now we saved the model, right? So let's go back to our experiment and check what it did. All right, so I guess we had the lowest RMSE here. All right, let's check it out. Great. So as you can see, we have the parameters here, and now we have the artifact, which is really nice. I'm really happy about it. This is the artifact, and you can see that we have an environment. This is a Conda environment, and we were using Python, but as I said, you can use Scala, Java, R, or really other stuff as well. And this really fills the bridge between, you can train your model in Python and like predict with some other language, or, just combine languages really. We have some MLflow related stuff, the description and our model. And, we like our model, so why don't we just go and register it, this time to the model registry. So we are going to create this new model. I'm calling this DataFast. Yeah, it already exists because I was testing it out before the talk, if it works. So register it. We are going to register it. The registration is still pending, but let me open it up. All right, so it's registered. And the way you can put it to production or get it ready to be tagged as a production model is you can just request transition to production in the stage field here, and comments computer says yes. And data engineers might come and check it out and approve or reject your request, and they say okay, and it will get ready, like it will be in the model registry for you. And there is an API in MLFlow, so you really can just query it. It's unrelated to Databricks, so it works like even not in Azure, anywhere else, and not in Databricks as well. So it's just an API. So we are gonna query it. As you can see, we have our models here as well. So it's just an introduction that you don't have to use Databricks. It works unrelated to it. Okay, we don't have much time. I will definitely answer and reply to your questions. Drop it, keep them coming. And if you cannot get to them, I will just reply to you right away after this talk. But one thing I want to show you is the MLFlow client. So we are just connecting to MLFlow. Again, this is unrelated to Databricks, and we are just iterating through our registered models. This way you can get an overview of it, so you can query it, and also we have a production model, right? So we registered this production model in the model registry just now, and we have the path here, so that is super nice. And this is unrelated to Databricks, so this is you can do it anywhere else. Also, you can register it as a function, this prediction function, and use it not in Spark, but for example Pandas as well. So we just set up a data frame in Pandas, for example, and throw on top of it our prediction function that we were using before, and it will print out our predictions, the RMSE, R-squared, or other predictions that we want. So this is a bit of a rush here. This part I rushed through it, but what I wanted to highlight here is that MLFlow is a very lightweight pip install way package, and you can use it. It's not like KuberFlow where you have to have Kubernetes to run it. Both of them are very actively developed. So yeah, that was it. I will send you all the notebooks, like the notebook and the presentation as well. And I will get back to the video right now. Yeah, 1 second. All right. Yeah. Okay, I'm back.
Thanks a lot, Miklos, for the
Of course.
talk. Before people start to ask questions, I'd like to ask one or two from my side.
Sure.
One is about the last point. So for fetching actually the models from model registry, you need to import the MLflow client from MLflow.tracking.
Yes, that's exactly right. So we definitely want to like connect to it to be able to query it. This is just a difference because in Databricks you can you have the Databricks file system here, but also like you don't have to have that. But what you said was totally correct.
Yeah,
So that's
just it
exactly
was a
right.
bit. It seemed a bit weird to me because like tracking is a separate model. You mentioned in the first slide, and registry model registry is a totally separate model, right?
Yeah, but we have to have the client, like the MLFlow client.
Yeah.
This way we connect to MLFlow, and this way we can query our register models or even whatever we want, and just print them out. As you can see, these are really just what it gives back for us is what we saw on the UI. So it queries actually the UI that you saw. I showed you the UI before in the webinar experiment or the DataFest experiment. So we get back this way the information about our model by connecting to MLFlow client, like with MLFlow client.
And do you are these all models stored in which way they are stored in the backend? In some DB or in some text files? All the information is stored.
Yeah, so everything is stored in a central repository. I'm very much like 90% sure it's like probably a DB, but I will double check it. I will double check it definitely and get back to you about it. Yeah, so we've been using MLFlow with Databricks like all the time. So I will get back to you. It's in Databricks, it's DBFS. In the Databricks file system, all saved or get saved into Databricks file system. Okay. But I'm not sure about when you're not using Databricks where it gets saved in a local kind of experiment or mode, because we haven't used that one.
Good. There's a question in the chat by Vaya Akokan. I'll read it out. Do you see it used in production scenario? And if not, what would you suggest as an alternative?
Of course. Very nice question. So this is a really good question. So MLFlow is, I said, I very actively developed, and like a lot of things changed from like 2 weeks ago as well. It's definitely usable, and it's developing in a quite fast pace, and it can be used in a production kind of way as well. If I could give you some alternative of what you would do is KubeFlow, probably KubeFlow. It's backed by Google. And I'm not familiar myself with Kubernetes, but you can use it as well as a alternative.
Thank you for the answer. I'll try to ask one more question. So you brought an example of MLflow applied to large GBM training.
Yes.
A similar concept is TensorBoard when it is applied to neural network trainings and deep learning in general. Of course, there are some differences, but the general concept is similar. So, of course, and MLflow can be applied in that scenario as well when you train neural networks, because all these logging parameters and metrics can be applied there as well. Do you see that MLflow aims to or can at some point become an alternative to TensorBoard?
So MLFlow, really, I think what they are trying to do is to build like not an independent kind of way of doing things, to work without any constraints, like any ML library, any language, any deployment environment. And I would say, like I myself don't know where they are, bringing this project towards, but I would say that what they are trying to do is to build a general purpose kind of way of doing things that we are doing as of today. So to work with anything, any organization, so from 1 person to like 1,000 person, scale easily, have model exchange easily, governance and tuning options. So this is what MLFlow is trying to tackle as of right now. That's 100% sure.
Okay.
Mike, to elaborate more, I'm sorry, Arsenjan.
Sure.
So as far as I understand, the biggest difference between this and TensorBoard is that in TensorBoard, you have the intermediate steps when you train your model, right? When we plot a chart in TensorBoard, we see how the model evolved over time. And here, as far as I understand, this is designed to handle information only at the end of the training. So when you have your model, maybe that's the biggest difference. And this is not designed to, for example, store models at every epoch, right? Or it is.
So yes, so what you said is actually I haven't used Tensor, so that's why I am not feeling qualified to answer your question. I don't want to say something that might not be true. This is probably because I'm coming from data engineering, but I will. So if you drop me a line via Slack or email, I have my data science fellows and colleagues here, and I will get back in 1 second about this for you.
Okay, thank you.
Sure.
Actually, I've used MLFlow. I'm using it for the last couple of weeks. Not.
Wow, that's great.
And it's possible to do this plotting during the time to see the track of the, for example, any metrics during time. So you can do plots in MLFlow as well.
Yeah. So really, actually, MLFlow is very well documented. So. And, it's a pip install way, just pip install it and you can try it out and break it. Because, I can give you an introduction, but I cannot do the, this is how you are going to pick up in the long run. So in the presentation, like every URL and every notebook is included. And I'm dropping actually right now into the Slack channel. I hope everyone is in the Slack channel. And you can, redo yourself, the notebook. And if you didn't understand some parts, my emails and everything else is open. Franz, should I drop it to presentation, generalized presentations? I'll drop it.
Yes,
to notebook as well.
Okay. Since there are no further questions at this point, I would like to thank again you, Mike, for the very interesting talk. And
thank you very much
supporting DataFest Yerevan and joining us as a speaker.